Hello, Yawning Angel, back again with another AMOS video. Yes, in this video we're going to be looking at sprites and how to handle sprites in AMOS. Now, we've already looked at icons and bobs, blitter objects, in previous tutorial videos, and this time I want to look at sprites. They're similar yet slightly different to bobs, so there's some things you need to be aware of. In my last video, I spoke about a free AMOS utilities program which was available from my website. Link to that up here. You're going to need a couple of the routines from that video, or from the program that was mentioned in that video, for the program we're going to write today. That's quite important, especially when we start looking at hexadecimal values for colors. So let's talk a little bit more about sprites. Okay, so I have to admit, sprites are not my strong point. They weren't back in the day, and they're still not now. I somehow struggled with them a bit, and I've had to do quite a bit of reading, especially out of the AMOS Pro manual, to understand a bit more about them. I cannot stress enough, if you can get hold of a copy of this, be it digitally or physical copy, do read up about sprites. It really will help your understanding. AMOS has a lot of functions and utilities built in to help you handle sprites and to get the most out of them. It's just getting your head around some of the routines and how they work, especially around colors. This was my stumbling block, and this is why this video is taking a little bit longer to get out there. I'm sure there are people out there in AMOS coding land who can do this a lot easier and a lot quicker than some of the methods I'm going to show you here, and if that is the case, well done you. I'm just not at that level yet, but I'm going to try and help you with the knowledge I have at the moment, and hopefully it will be a benefit to you in some small way. Right, what we're going to do then, we're going to have an IFF file that we've created in a graphics package that has some objects on there, some images on there that we want to use as sprites. We're going to load that into an AMOS program. We're going to cut those images out and assign them to sprites, and then get one of the sprites and move it around the screen with a joystick. Dead straightforward. There are a number of ways of doing sprites, getting them into your AMOS program. You can load them from an image bank. Now, we've done that with bobs. You can do that with sprites as well. But for this video, we're purely going to look at creating those images in a graphics package yourself, and then loading that IFF file into AMOS and cutting them out and assigning them as sprites from there. That way works quite well for me, and I hope it will for you too. Please don't forget that all the source files for this program will be available on my website, so there'll be a link down here somewhere to the downloads page. You'll be able to get the AMOS source code, and I will include the IFF file that is used with this program as well to help you out. But please, please, please feel free to go ahead and do your own graphics. You will probably get more mileage out of that, and they'll probably be a lot better than the graphics that I can come up with anyway, because I ain't no graphic artist. Sorry. Okay, here I am in Personal Paint, and in here I have already created a file that has 4 images on it, so I'm just going to load that in to show you what that looks like. Before I do though, please take a note of the the file dimensions. It's a 640 by 256 and 16 colors file. You need to know this because we'll need to have this for our AMOS program when we write it. Okay, so let's load that in, and here we go. So I've created these 4 heads, as it were, and each one of these is going to be a sprite. When we're going to load this file into AMOS, and effectively we're going to cut these out and assign them to sprites, and we'll be able to do stuff with them. It's really cool. Please excuse the lack of any artistic talent that I have. Like I say in all these videos, I'm not an artist. This is the best I could come up with in the time in order to demonstrate the functionality. So anyway, there you go. This is our file. So let's get on and write the AMOS program that can take these images and turn them into sprites. Easy. Right, so I've already started to create the program. Usually with these things, I do all the comments first and then we fill the code in. With this program, this time I've actually started to put some of the code in already, because this is stuff that we've covered time and time again, and I don't want to teach people how to suck eggs basically. So things that we've already covered, I've already got in here, and we'll fill in the blanks as we go along. So by the way, if anyone's wondering why the screen looks a little bit narrow, it's because I've made some changes to the resolution. So the OSSC that's doing the video capturing gets a better resolution for you, and this incidental piece of footage, it will be small, but it's fine. It's not paramount to what we're doing, so don't worry about that. I'll turn it all back. later. Okay, so what we do then, well, first thing we're going to do is open the screen and configure it. So this needs to be the size of the IFF file to load. So our IFF file was 640 by 256. That's what I'm setting this screen as. 16 colors, and it's a low-res screen. We turn the cursor off and we turn any flashing off. We're then going to do something called set the sprite buffer. So we'll do that in a bit. We set up some global variables. We'll see these later on. We then load and obtain the sprites. We then close screen 1 because we're done with it. And then we're going to open a second screen at the desired size and resolution. We're going to, just by way of a utility, we're going to show what colors we've got for this screen when we open it. Then we're going to get the sprite palette, so the color palette from the IFF file that we've loaded in and taken the sprites from. We're then going to clear that screen. We're then going to set the sprite palette colors for use on this screen, and then we're going to show the colors for this screen after getting the sprite palette. And what will happen here, you'll see a difference between here and here. So because there'll be a different color set will come in, a different color palette. Clear the screen again, and then we're going to put the sprites on the screen. Then we're going to handle movement of the sprites by control of the joystick, and then we'll end the program. So what I've got in here, I've got some procedures already written. Some of the stuff, if you saw my last utilities, AMOS utilities video, this stuff is in there. So showing the colors, the hexadecimal values for the colors, there's routine already there. I'll put a link up above somewhere for you to go back and see that if you haven't already done it. We're obviously dealing with the sprites, so we're going to need to load a file in, and we've got some screen coordinates that we're going to have on the display, so you can see where you need to set their coordinates in order to cut the sprites out. Don't worry, I'll come on to that. And then we're going to set the colors. We need to write the code in there, and that's pretty much it. So it's a fairly simple program once you break it down into its constituent parts. Right, okay, so we need then to get on with the coding, so let's do that now. Right, so the first thing we're going to do is set sprite buffer. Yawning Angel, what is sprite buffer? So according to the AMOS manual, which I have here, the sprite buffer command allocates extra memory for hardware and computed sprites to work within. So each hardware sprite can be up to 270 lines in height. AMOS Professional reserves sufficient memory for 128 lines by default. So if you're using computed sprites, which is what we are, it's more practical to extend the sprite buffer number to a larger value. This is economical on memory since each line only consumes 96 bytes. Thus, a maximum height of 256 would require about 12K of extra memory. So what I'm going to do, just as a belt and braces, I'm going to set sprite buffer to 256. Now I can tell you this makes no difference to this program because of the size of the sprites we're using, but I think this is definitely a good practices thing to be doing. So that's what we're going to do. So sprite buffer is set. We've then got some global variables, X, Y, and SSP. You'll see them crop up later on. So load and obtain sprites. So I've already got a procedure for that. Let me just try and find it. Set colors, no. Deal with sprites is the procedure. Oh, bear with me. So what we want to do then is deal with underscore sprites. That'll be the procedure that we use. So let's dive down into there. So here we are. So what we're doing here, we're going to load the IFF file, the one we created earlier, and get the sprites from it. Because effectively we're going to load that in, and then we're going to determine where the coordinates are for each sprite and cut them out and load them into a sprite. So the first thing we're going to do is load the IFF file, sprite underscore heads.iff. This file is in the same folder as this program code. If it's not, you will need to set a directory to point it to that. But if you keep everything in the same folder, it just keeps things a little bit easier. I've got a message here, click left mouse button to exit this stage. That will become clear in a minute because this literally is a utility piece of code and will not form part of the main program. We're going to have this code show our X and Y coordinates on the screen as we move our mouse around. Once again, this piece of code exists in the utilities program, which was featured in my last video. Once again, link up above in case you missed it. So that just runs in a loop, basically, so it's showing us where the coordinates are. So what we need to do then is get the sprites from that IFF file. So what we're going to do, so the format of this is we're going to use the command get sprite, and it's then got an image number, then we've got top left X and Y coordinates, and we've got bottom right X and Y coordinates, which we need to capture, and that's really it. So let's dive in and do that. Bear with me. Okay, so if that's the format, we're going to need to know those coordinates. So the way the program is structured so far, I can actually run this. So if I press F1, what we get on the screen here is we're showing our X and Y coordinates, little message, click left mouse button to exit. Once again, this is just utility part of the program and will not form part of the main code. But this is just going to help us understand what coordinates we need in order to cut these out. So for my first sprite, then my X and Y coordinates are going to be 176 and 96 to, down here should be 192, 112. So that corresponds to that corner. So it's a case of just moving your mouse to the top left and the bottom right, and that will give you the coordinates. So this sprite down here will be 176, 119, that's our top left coordinate, and our bottom right coordinate is going to be 192, and that should be 135, 135. And yes, I am looking off to the side because I've done this before and I just need to make sure these numbers tally up. So that gets us the coordinates for that. Likewise, we do the same for the orange one. Top left, bottom right. So the bottom right there is 256, 112. And then we do the same for the yellow one. Go up into that corner. 240, that should be 119. And then down here to about 256-ish. 256, 135. We'll do that one. So those are those coordinates. I have already got them here, give or take the odd pixel. These are 16 by 16, by the way, in size. So click left mouse button gets me out of there. So right, so let's do this now. So get sprite 1, and those first coordinates were going to be 176, 96 to 192, 112, and rem. So that should be the green sprite. With it, they move the mouse. I always leave the mouse over the code. I do apologize. We're going to do the next sprite, which will be image number 2, and that's going to be 176, 119 to 192, 135, and that should be blue. Get sprite, third sprite now, and that should be 240, 96 to 256, 112, and that should be the orange sprite. And then the last one, which will be sprite 4, is going to be 240, 119, and that's 256, 135, and that should be yellow. Right, F3 to line that code up. So effectively, save that. So Amiga S to save. So if I run that, we're not going to see any difference, but apart from the fact the program doesn't crash because there's nothing wrong with that code. So that has got our sprite. So image number 1, 2, 3, and 4 have been loaded with these values. So tidy that bit of code up. So that's that done. So let me go back to where I need to be. We have done the deal with sprites. Right, go back up here and deal with sprites. So now what we want to do is close off screen 1. We have no need for screen 1 anymore. So screen close 1. Very simple command there. Then we need to open a second screen at our desired size and resolution. Screen open 2, and this will need to be 320 by 200, 16 low res. Of course, you can do whatever size you like. I'm just doing this for this particular video. We'll turn the cursor off. We will also turn the flash off, and we will hide. Hide on is for hiding the cursor when we are dealing with sprites. So now what we want to do is show the colors for this new screen. So all we're going to do is call the subroutine, or the subroutine, the procedure hex color. Now I am passing a parameter into this, and what I'm passing in are the words opening screen 2. This is just really a little comment to show whereabouts in the process we are. So, and this is, we've just opened screen 2. You'll notice I haven't issued a clear screen command yet. There's a reason for that. So what we're going to do is just pass into our hex color procedure. Let me dive down here. So here we are, hex color. This is it here. And we're receiving a value, reason string or reason $, and we've got just some basic information here telling you whereabouts we are in the process, and this is once again just for information. So there's a wait key command at the bottom of this as well, so we wait until the user presses a key before moving on. So F2, no errors. So let me do this. We don't need to do anything here, so I can just click the mouse to move on. And here's our screen 2. So as you'll notice, these are the hex values of the current palette after opening screen 2. So this is what we've got. So I would suggest just take a little note of these, because you'll see these change in a while when we've written the next piece of code. So I can hit space, that's the end of the program. All good. So where are we? We've back up here, we've called our hex color routine. So now what we need to do is get our sprite palette. So get sprite palette. It really is that easy, and this is why I love AMOS so much, because these procedures and routines are hard baked into the program, to the program structure. So you just got to call them. When I did Bobs, we were looking at Bobs initially, there was a get Bob palette. It pretty much works the same way. So that Bobs video, go back through my AMOS videos. I'll try to put a link up here somewhere, and you'll be able to have a look at that if you haven't already done so. Now we're going to clear the screen to color 0, like that, which is all good fun. And yeah, that's all good. Now what we need to do is set the sprite palette colors for use on this screen. And to do that, we're going to call a routine called set cols. Okay. Now this is where things get a little bit complex, and it took me a while to get my head around this. So we've got 16 colors. So colors, actually let me go in here and show you. So we've got 16 colors, 0 to 15, they're set already. But what we need to do for sprites, computed sprites are using, now I could stand corrected on this, but they're using color registers from 16 to 31. So what we need to do is load in the colors from our sprite palette, and we need to push them into registers 16 to 31, so our sprites will use them. Please read up on this. If you have the AMOS Pro manual, please do read up on this. It takes a while to get your head around, but effectively these are our colors 0 to 15, which is 16 colors. We get our sprite palette in. These will change because it takes the palette from the IFF file that we've loaded in, and then we need to take those colors and force them in to position 16 to 31, so our sprites will use those colors. And I will show you later what happens when we don't do that. It all goes horribly wrong. So let's go down to set cols, and let me find that route. There we go, set colors. So what we need to do is to assign the color registers 16 to 31, and we need to do this manually. I've tried to come up with an automated process to do this, and I failed abysmally, and it didn't work too well. But that was the way of things. So what we're going to do in here is just assign those colors, but you're probably saying, Yawning Angel, How do we know what those colors are? Well, we're going to write a piece of code to find out what those values need to be, and we're going to do that next. Right, so we've already got, what we need to do basically is find out what the hexadecimal values are of the new colors which have loaded in off the get sprites palette command. So I'm going to go back up here to where we do the set colors. But before I do that, I'm going to put a call back in to our procedure hex color, and with the comments we're going to give this is after getting sprite palette. This is important, and this is going to show us what the hexadecimal values are that we then have to assign to color registers 16 to 31. Now if you watch my last video on the utilities, the AMOS utilities, this is why I did actually make mention in there that when we come to do sprites, this particular getting the hexadecimal values of colors is actually going to be quite important, and this is why. So I run this program again. I can just click left mouse button to skip this step. These are my colors as the screen opens. So these are the colors that AMOS has just defaulted to. So now I'm going to press the space bar. We've got the sprite palette, and now we've run the same routine, and as you'll notice, all the colors have changed. So this is the hex values of current palette after getting sprite palette. Bit of a language thing there, just excuse my grammar. So these are the hexadecimal values, and what you're going to need to do is make a note of these. This one that's in white and white, yeah, we'll probably need to change the ink just to show what that is. You can do that quite easily within the code. We'll do that in a little bit just to show you how that's done. But you need to make a note of these values, because these hexadecimal values are the values we're going to put in the program. So press any key. Let me just quickly dive down into there. Yeah, so ink is C. So let's tell you what I do want to do. Let's run this program again. Bear with me. Let's do ink as 1 on this. So bear with me. So if I do ink as 1 now, run that and click left mouse button. Or now press any key. That didn't work. Why didn't that work, Yawning Angel? It's all gone horribly wrong. That is not right. This doesn't need to be ink, it needs to be pen. Let's try this. Click. There we go, that's better. Although we can't see the black now, but that's not a problem. But at least it'll tell you what that is for the white. So there's a bit of a muddle fix around, but don't worry. Make a note of those values, and let's get them keyed in to the program. So let's change that back to 0. Right, okay, so what we need to do now is go down here to our set colors. And really, it's a little bit of a laborious task, but this is what you've got to do. And there may well be a quicker way of doing it out there. If you know, please let me know in the comments down below. So color 16 is going to be $CCC. Color 17 is going to be $0. Color 18 is going to be $FFF. And to save you watching me typing all of these in, I'll go away and do this, and we'll come back at the end and I'll show you what I've done. Okay, I have assigned colors 16 to 31 with the hexadecimal values. So let's go back up here. I've done a bit of tidying up at the top of the code as well. So what we did there, we went in and we got the hexadecimal colors after we obtained the sprite palette. So we got the sprite palette, we cleared the screen, we went in, we then showed the colors. We've now set the colors, and what we're going to do again here is just show that nothing has changed in 0 to 15. Those colors have stayed the same after we've done the set colors, because we set the colors from 16 to 31 in the memory registers. So let me just save that and run this. So we'll click through here. We've opened a new screen. Those are the colors and press a key. We now get the sprite palette. After getting the sprite palette, this is what they are. And after setting the colors, excuse my rubbish coding here, I didn't mask that out, never mind. But after we've set the colors, these colors haven't changed. 0 to 15 have not changed. What has changed in memory though is positions 16 to 31. And I will show you later what happens if we don't do that. Okay, so now let's just go up. So we've now done all of that. We've now got to put those sprites on the screen. So here we go. Stick with us. This is starting to get exciting. So what we now use is the sprite command. And the sprite command is sprite and then the sprite number. So we're going to assign sprite 8 will be positioned at 280, 120, and it's going to use image 1. This is very important. So as you'll see, there's a comment in it that says computed sprites start from 8. In the AMOS manual, computed sprites, which is what we are using, start from 8. They go from 8 to 63. So what we're doing is sprite 8. Our first sprite is using image 1. Remember when we did our get sprite, that was 1. So we're now taking that first image and we're loading it into sprite 8 and we're going to position it at those coordinates on the screen. Let's do sprite 9, which will put up position 280, 150, and that's going to use image 2. Sorry about the mouse. I always leave the mouse in the way. Sprite 10 will be positioned at 320, 120, and we're going to use image 3. Okay, can you guess what's coming next? Sprite 11 will be at position 320, 150, and we're going to use, wait for it, image 4. Ta-da! Let's see what that does. F2 for no, there's no errors there. We'll quickly save that. Let's run that program. We don't need this, don't need this. We can skip through this, skip through that. And look at that. We actually have those 4 images now. Those sprites are now placed on the screen. You can put them any way you like. It doesn't matter. I've just chosen to put them here. So there they are. Yeah, the green, the blue, the yellow, the orange. Those sprites are positioned there. Brilliant. It's dead easy. Really is dead easy. Now what we want to do is delete all this blank space. We're now going to handle moving the sprite because we want to move a sprite around the screen. So let's go into the move sprites procedure. Here it is. I haven't actually written it yet. There we go. Handle the sprite movement on the screen. Let's bring that code up. Right, so here we go. It's the exciting bit. Stick with us. We're going to set an X position of 280. We're going to set a Y position of 120. We're then going to set SSP equals 1. And what this is the starting sprite image number. Okay, so image 1, we're assigning to there. It'll all become clear in a minute. We're just going to do a bit of housekeeping. I want to just put a message in here, 0, 2, print, paper 0, pen 5, print, click, fire. I'll tell you what I do need to do. I need to put this in some quotes. Come on, you're an angel, you're getting slack. Click fire button to exit. Okay, right. Now we need a do loop. And let's go. So if joystick up 1, the joystick is moved up, we want to set our Y coordinates. So Y equals Y minus 2. There are other ways of doing this. This is the way I'm doing it. SSP will now change to image 3. Okay, endif. Oh, it's a syntax error. Print. Click. Yep, there is a syntax error there. Look at that. Slack coding, Mr. Yawning Angel. Right, press F3 just to indent that code. Okay, next, if j down is 1, so if the joystick is moved down, we're then going to change our y equals y plus 2. SSP is going to change to image number 2. End if. Then we're going to go j left is 1. Oops. We're going to do x equals x minus 2. SSP equals 1. End if. Okay, and then we're going to do, I've missed out j right. I need to do j right. That's what happens when you read from something off of screen. You miss stuff. So if j right 1, and that's going to be x equals x plus 2, SSP will equal 2. And end if. Right. So what we're doing then, if the joystick is pushed up, we're going to reduce our y coordinates by 2. We're going to change the sprites to image 3. If we go down, we're going to increase y. We're going to set our sprite image to image 2. If we go right, we're moving our x coordinates. We're going to change the image. No, that's wrong. That shouldn't be 2. That should be j down. I've gone wrong here, because that, ladies and gentlemen, should not be 2. That should be 4. Right. So if we go up, we change it to 3. If we go down, we change it to 4. If we go right, we change it to 2. And if we go left, we change it to 1. Brilliant. And don't forget, because you're moving an object around the screen, we need the wait VBL command. We've seen this command before. This is cropped up in our Bob's video. Do take a look at that if you need to. But now we're thinking about how do we actually get that sprite on the screen. So what do we need to do now is issue another sprite command. And this, what I'm going to assign sprite 12, position it at x comma y, and whatever image value we've assigned. So what this is saying, we've already got sprites up to, so we've got sprite 8, 9, 10 and 11. We've already put those on the screen, but this is a whole new sprite, and we're going to say that sprite 12 is going to be positioned to x and y, and we're going to give it the image either 1, 2, 3 or 4. It's really that straightforward. So let's tidy this up. So let me, there's no errors, save that, so we'll do that. So I don't need this, we can just key through this. Now we have this screen. Right, moment of truth, I'm now going to move the joystick. And there it is. There's our sprite, and as I change direction, the sprite image changes because we're changing it in our code. We're saying that on a move of the joystick, that sprite image has to change, and it's doing that. So as we go down, we get the yellow. As we go up, we get the orange. We go right, we get the blue. We go left, we get the green. That, ladies and gentlemen, is how to cut out some sprites from an IFF file, load them in, set them as sprites within your AMOS program, and then be able to control a sprite using the joystick. That's it. Dead easy when you know how, isn't it? Awesome. And we press fire to exit. We would press fire to exit, but somebody's forgotten to put the fire code in there, haven't they? Let's quickly change that. So what I need to do here is if fire is 1, exits end if. That was a bit embarrassing. Let's try that again. Skip through that. Don't need that, don't need that, don't need that. We're moving around. Here we go. And press fire button to exit. There we go. The code exits. Brilliant stuff. But you need to know this. Right, so with that code run, I said I was going to show you what happens if we don't set the colors correctly. And this underlines why it is so important in this program to make sure that you do set the colors for your sprites, otherwise it will cause you a world of pain. So what I'm going to do here, so this is where we called the routine, the procedure set colors. I'm just going to comment that out. Save that. So what's going to happen now, we won't be setting the colors after we've got the sprite palette. We're still going to get the sprite palette, up here, but we're not going to set the colors 16 to 31. So I'll run this. So once again, we can skip this stage. So here we've opened our second screen. Those are our colors. We've now got the sprite palette and it's loaded in, but it's loaded in from position 0 to 15. Because we are not setting the colors from 16 to 31, if I press space, so obviously this code still rumbles, so it thinks we have set the colors, but we haven't. But look at this. Look at the state of our sprites now. Are in the weirdest shade of colors. We're all like in blues, whites, and light oranges and all the rest of it. The code is still working, excuse me, but the sprites have the wrong colors because the sprites are taking their colors from positions 16 to 31, and we haven't set those. So this is why everything looks like a bit of a dog's dinner on the screen and is completely the wrong colors. This did snag me up quite a bit, and I did struggle with this for a while. I didn't have this problem with Bob's, but with sprites take their colors from 16 to 31. Obviously, if you're using more colors, that will change, but no, for this program, 16 to 31 we haven't set now, and it looks like a bit of a mess. So what I need to do now is go back in and let's just uncomment that. So now we will set the colors. So let's go click through here. We don't need that. And the colors are correct now because we're assigning the right colors into those memory registers between 16 and 31. I know I keep banging on about it, but it is really important, excuse me, it's really important that you do that, otherwise you will cause yourself a world of pain. So please take note, it's really important. It's important, you know, yeah, really important. And that's it for another video. Thank you ever so much for watching this. I really do hope it has been of some use to you and you'll be able to get something out of it. Don't forget, I do a number of these AMOS tutorial videos. There's a link up here to the AMOS tutorials playlist. It's just all my own code. I do this for fun. Obviously, there are people out there with more experience who could probably make this code a little bit more efficient and do things slightly differently. That's all good. Whatever works for you, that's fine. Okay, thanks once again. You can find me on the socials, the Twitter, the Mastodon. I have a website. Obviously, you can go to that website to the downloads page. There'll be a link down here. You can get the code for this program and relevant files. I'm also on Ko-fi as well. If you want to support me on Ko-fi, that is all well and good too. There's a link flying around the screen here somewhere. All of this information is in the video description down below. And that's it. So thanks once again. Take care of yourselves. Whatever you do, keep it retro.